Hello and welcome to the Mining Journal panel discussion on the future of tailings. The Global Industry Standard on Tailings Management was published in August 2020 following a lengthy review process involving mining companies, institutional investors and other stakeholders. Shortly after, Mining Journal, together with partners FL Smith and Isometrics, ran a survey of mining industry leaders where we gathered their thoughts on the standard and on the best technologies to help achieve the standard's zero harm goal. The purpose of today's panel discussion is to discuss some of the results of that survey and to form a picture of which technologies will be used in tailings management going forward. I'm Nadav Shemel, Mining Journal contributor, and I'll be moderating this discussion. Our participants are Robin Bolton, Executive Head of Sustainability at Isometrics, a leading supplier of governance, risk and compliance software to the mining industry. Todd Wisdom, Director of Tailings Solutions at FL Smith, a multinational engineering firm specializing in mining and tailings facilities, and Evgeny Monachov, Head of Investor Relations, Polymetal International, a precious metals mining company with 11 tailings facilities in Russia and Kazakhstan. Let's begin with your impressions of the standard. So in our survey, a slight majority of 53% said the standard would adequately satisfy all stakeholders, but then 60% said it would not achieve its stated goal of zero harm. Robin, we'll start with you. What are your takeaways from the standard, and do you think it can achieve its goals?
Yeah, hi, Nadav and my fellow guests and everyone listening in. So, to be honest, I actually was a little surprised with those numbers, those percentages that came back. I thought there would be a higher number believing that the standard would adequately satisfy all the stakeholders and as well as achieving that ultimate goal of zero harm. But I'm also aware that zero harm is a very ambitious statement or goal, and that the nature of tailings dams has an inherent potential to contaminate. So again, a little surprised by those numbers, but I think what this perhaps indicates is that it's very difficult to satisfy all stakeholders, and there needs to be some compromise along the way. From the launch of that standard several months ago, it was apparent that those co-conveners had done a very thorough job in trying to incorporate the right stakeholders. I think they even delayed the release to make sure they engage with the right stakeholders. So they did try to develop that guideline to meet all of their needs. This might also indicate that the requirements of stakeholders differs significantly, and you'll never be able to satisfy all of them. I think that is understandable. Or perhaps that the standard wasn't prescriptive enough or detailed enough, and that they feel that it might fall short in the implementation part, why they just didn't feel it would meet its required goal. So again, coming back to the sort of why perhaps it wouldn't meet its goals, a couple of other points or ideas I had is that it needs to come down to those companies taking action to actually implement this guideline now and align their current processes, their current practices, their current procedures to this new standard. And again, this could be costly in some cases. There might be a change of culture that is needed. And interesting enough, just from some recent discussions with a large gold mining company with global tailings facilities, they're spending and rushing and spending a lot of time just trying to align their different operations practices to this new global standard. They find previously their operations were quite autonomous in the way they operated their facility. So there's a big drive to actually align the practices to this new standard. So there's quite a lot out there that has to be kind of gathered in, brought together, and aligned to ensure that the companies try and meet this ambitious goal of zero harm. So it's definitely not going to be a quick thing. It's going to take a lot of attention to try, as I say, get practices aligned, get operations aligned, and even within a company, get their different sites aligned.
Okay, Todd, I understand you were hoping the standard would be a bit more prescriptive.
Yeah, kind of building on what Robin said, with the goal is zero harm. I think you really have to look at, where have the failures been on tailings dams globally. And if you look at the numbers that are out there, significantly where the main failures have been, and the majority of them and the ones that have caused the most damage have been on the upstream construction design type of dam. And so I really think that if the goal is zero harm, that the standard could have said we're not recommending that type of dam construction anymore. And I do realize you have a lot of stakeholders you need to be able to represent and to be able to satisfy, which makes it difficult. But due to just the severity and the construction methods for the upstream dam, that it makes it really hard to understand what the foundations are. You're building on top of old tailings. Tailings are variable, so it's a variable material you're using to build the dams. That just due to the technological constraints, that if you do everything perfect, it's going to work. But how in the real world does everything go perfectly? So I really do think that if the goal is zero harm, they could have eliminated the upstream dam type of construction, and that would have made it probably much more safer in terms of what's being built out there in the world today.
And Evgeny, as the operator of a total of 11 facilities in Russia and Kazakhstan, what is Polymetal doing to process the standard, the recommendations in the standard?
Hi, Nadav. Hi, dear panelists. Thank you very much for your question. The board of Polymetal, as soon as the new standard has been published, has mandated the management of the company to analyze the document and prepare a report that will lay out sort of the steps that need to be taken in order to align our own internal policies on TSFs with the new standard. We, as you said correctly, we run operations in Russia and Kazakhstan. We are not, a global company with like autonomous operations across continents. So we stick to a very rigid and strict sort of policies on TSFs internally. But we need to make sure that on all levels, these policies correspond or meet the demands and the challenges that the new standard provides. And just to give you a little bit of a flavor, the amount of work that needs to be done in order to make sure that these documents sort of correspond to each other, we operate on the basis of federal laws and regulatory documents, the technical supervision authority methodology requirements. We have internal documents like the policy on water storage facilities. We've got standards of environmental management system and the occupational health and safety system. These are all, documents which go in hundreds of pages that basically completely sort of set the rules and the parameters of how these storage facilities are designed, built, operated, monitored, and closed after their useful life. So the process is ongoing. We have been set a deadline at the end of the year to prepare the analysis and report on the standards. And in November, we will have a board meeting where the management will present its findings. And the board will, on the basis of those findings, will make a series of recommendations of where we are and what we need to what needs to be done to meet the standard.
Okay, before we move on, would anyone else like to comment on just the overall impressions of the standard?
Well, if I may jump first, it's a big document, 15 principles, 77 requirements. So as an operator of 11 tailing storage facilities, we find the scope of the document to be quite large and deep. And so we are now, the various teams at the company are working basically to make sure that every principle and every requirement that the standard has, we're trying to understand what does it mean for us as an operator of these standards. Because sometimes the standards overlap and the requirements overlap, but not 100%. We need to make sure that, how much do we overlap, whether the areas where we do not overlap are material or not, and who is to make that call, who is to say that those areas where we do not overlap at the moment are not material. So it's a very painstaking and a very, I would say, labor-intensive process where we need to make sure that not only the letter but the spirit of the document are properly reflected in the standards that we adhere to.
Anyone else?
Yeah, I think I would add that, we have a lot of touch points with a lot of mining companies around the world. And I really do see an effort by these mining companies to digest this large document and to try and implement it across their organizations. And for some of them, especially the tier one global companies, that's a big effort. They've got mines all around the world, tailings facilities that are open and closed. And they are making a concerted effort to try and improve the safety around these tailings dams and using the document as a guideline on how to do that.
And Robin?
Just to add, I think Evgeny summed it up perfectly. The spirit of that document must be embraced, and understanding the material risks. If you can get that out of what the guideline is proposing, then you're achieving that objective of actually managing that risk. So that was nicely put there.
Okay. Thanks, Robin. Okay, to move on. From the beginning, the standard co-conveners declared they would not favour any technologies, which is understandable. But obviously, it's our job on this panel to discuss these things. So firstly, I want to note that 63% of our survey respondents said mining companies were somewhat willing to implement new technologies at tailings facilities, and 27% said very willing. And when asked to give a score out of 1 to 10 as to the importance of 4 specific technologies in the near term and on a 10-year horizon, all the technologies achieved scores around the 6.5 to 7.4 mark, suggesting they're all fairly important. In tailings monitoring hardware ranked first of the 4 in near and long-term considerations. Integrated communications networks and tailings thickening ranked second and third in the near term, but filter tailings actually pushed them aside for second place on a 10-year horizon. So, Todd, as head of tailings for a major mining engineering firm, what do you see as the most important technologies going forward?
Yeah, thanks for the question. So, FL Schmidt supplies technology for dewatering tailings before it goes out to the TSF. And what I see is getting the water out of tailings is what's going to make it safer. And as the respondents have correctly said, the first step in that is thickening, followed by filtration, and then maybe some other technology. So I'll touch on each of those briefly. High performance thickening, high density or paste thickening is usually what it's called. I do think is probably the biggest player in the near term. Those types of technologies are used pretty prevalently in smaller mines today, but as we see newer, bigger mines successfully implementing this technology, like Centenalia in Chile, what you're talking about mines that are producing 90,000 tons a day of tailings and successfully implementing paste or high density kind of thickening. And then that means the material has a bit of structure to it. It doesn't want to flow like water. It looks a little bit like the toothpaste you have in your bathroom. When that material goes out to the tailings storage facility, there are special ways that you have to use to deposit it and make sure it stays where you want it to, and have the ability to move it around so that as you produce more of it, you can make a nice tailings storage facility that's safe and also recovers water for the mine. Large mines, like I mentioned, Centenalia is successfully doing this now. So you're seeing other mines plan to implement this On even bigger scales, maybe 150 to 200,000 tons per day. The challenge is the actual placement of the material because it doesn't want to flow like water, but it's also too wet to actually drive on. You can't move equipment on it immediately. And so there are special techniques that need to be used for the actual placement of the material at the TSF. I also agree with the respondents that probably in the longer term that filtered tailings is going to have a bigger, more prominent role. Filtered tailings right now is used almost exclusively less than 30,000 tons per day, with the largest operating facility being an iron tailings facility in Western Australia at 30,000 tons per day. But we're seeing people study filtered tailings technologies at larger scale for 100 or 200,000 tons per day. The issue there is you require multiple pieces of equipment. And when I say multiple, I mean a large 100,000 ton tailings facility right now might need 10 to 20 big pressure filters to dewater its tailings. And 10 to 20 of anything is difficult for a miner to imagine operating and maintaining, let alone a big pressure filter. So the drive now is to make a bigger scale pressure filter, of which FL Schmidt has done, and there are other people that are also doing that. The challenge there is to get the first one installed and prove the technology. Because miners also don't like to take a lot of risk on installing the first one. And I think later on we'll discuss about some ways and barriers of entry for some of these technologies. Past filtered tailings, there are some other technologies which I think are important that are on a bit maybe longer term horizon. There's things like coarse particle flotation, which allow you to generate really large particles that might dewater easily. There's dry grinding, which allows you to not add water to part of the stream. And as I said, if you get rid of the water, you don't have issues with the tailings. So there are other things that are further out, I think, in the timeline, which can very definitely benefit the dewatering of tailings and the placement of tailings and the safety of tailings.
And Robin, in your position representing a leading supplier for management risk and compliance software to the mining industry, which technologies do you see being most important to securing and managing these tailings facilities?
Yeah, thanks. So yes, I can answer that from my experience working with software, and my particular role is in the environmental, social, sustainability sort of realm and risk management. So what we've developed and what we've seen the market sort of needing is really something to provide the right data. And I always say, you've got to have the right people access to the right data and at the right time. And if you've got that in terms of sort of monitoring your tailings facility, well, you're on top of that game. So, and let me just elaborate a bit about that data. So gathering that data, yes, it means devices. And yes, there's technology around now that can gather those sort of metrics, be it environmental data such as water qualities or dust fallout levels, perhaps more operational aspects such as perhaps freeboard height or piezometer pressures, and production data, the amount of tailings going to your dam. So all of that can be measured by devices which are commonly available. Let's call it that hardware. But then it needs to go a step further. You need to be able to gather that data, bring it to the edge, and where IoT companies come in is they can then sort of gather that data, make it available in some sort of platform or layer that then is available to a user. And we're fully aware, and we see that, we can talk about mass data. There's a lot of information that can come from these devices. Now, where it goes is the next question. So it can get stored in massive data lakes or other facilities with certain sort of rules set where perhaps, a exceedance of a preset limit would then notify the right, or else, if a certain reading is out of sync, it can trigger a response or something along those lines. And even at the end of a week's data, maybe there's an average that gets sent through to a user or an operator. So there's a lot that can happen in that IoT space. So we're definitely seeing a lot of progress and a lot of advancements in that particular area. Where I'm also familiar with working in is on the management system side. So it's one thing gathering that data, but then it's got to be sort of managed and analytics applied to it so you can actually start understanding that data. So Being able to have it in a management system, being able to see displays of that data in the right graphs, charts, tables is certainly where we see interest. And another concept I just want to touch on is, this concept of an early warning system that we talk, a fair amount with people we engage with in the mining industry is that early warning concept. So, for example, you might have a facility in a high rainfall area, and there's a weather station picking up this chance of a high rainfall event. Plus, your metrics on the dam are indicating that you're at full production and you don't have too much freeboard capacity or simulative capacity left in the dam, and therefore these three metrics can equal a high risk situation, and an alert or notification can go to the right person. So again, you're bringing in some sort of intelligence to notify people about pending risks that might come up. And then lastly, again, where technology can help is, the right person seeing that data. So for example, if an operator would want to see different information than perhaps an officer that's got certain duties versus a more of a management person that needs to see sort of rolled up information. So again, you can display information to different people in different ways. So definitely that's where we see in the sort of GRC space where technology is helping.
Okay, and Evgeny, I understand Polymetal has already begun pivoting from, prior to the standard, had already begun pivoting from wet to dry tailings. Could you share details about this initiative?
Yeah, it was a few years ago, shortly after the Samarco mine disaster, that the board has decided that we will be building only dry stack tailings facilities starting from that time. And since then, we built 2 dry stack TSFs. So out of 11 facilities that we run right now, 2 are dry stack. And we continue to move along sort of the increasing share of dry stack in our overall tailings storage. As of last year, that share was 10%. We hope to get it to 15% by 2024. Our production is growing. We are a growing company, so that target looks quite modest. In the medium term, we think it's quite a challenging and ambitious target for us because it's again done against the background of a growing output from our mines. We will be building new projects, and we're building 2 at the moment, only with dry stack storage facilities. And we are at the moment conducting a research and analysis of our wet TSFs to understand where it's feasible to replace wet TSF with a dry stack. We have identified one such facility in one of our operations in the northeast of Russia, in Magadan, and we will be replacing that facility with a dry stack. The challenges are, of course, enormous in operating and at the same time trying to replace the existing facilities with dry stack. But we are confident that we will be reaching all of our targets, which were stated in our sustainability report.
As Todd mentioned earlier, there are a lot of challenges as well. So I'd like to talk about the barriers to technology implementation. So firstly, in our survey, when asked about the barriers to using newer technology to improve tailing safety, the most popular answer was, the answers were fairly evenly spread. So the most common answer with 34% was limited proven operating installations. Todd, I think you actually hinted at that before. 27% said perceived poor return on investment, 24% said lack of regulations requiring technology, and 15% said high risk of implementation. And furthermore, on costs, around 9 out of 10 respondents agreed the standard would increase the sustaining costs of tailings storage facilities, and around a third said costs would increase by 15% or more. So, Robin, we'll start with you. What do you see as the main barriers to new technology implementation, and what are some of the potential ways to overcome these barriers?
So yes, I mean, it's definitely evident from those responses that tailings operators and those involved with tailings storage facilities aren't yet fully convinced by technology or certainly new technology. And that's fair, and some of the reasons that I can come up with is that, there's been rapid advancements in technology and what it can bring to industry and mining operations, and even specifically to tailings storage facilities. And perhaps the market's not really aware of these rapid advancements, or else they're just not convinced that there are benefits, and they're waiting perhaps to see the sector mature a little bit, or even a case study. So it's one of those where perhaps you need a reference site, one operation to have implemented this new technology that's available, or made use of it and gone through that process, and that becomes a reference site, and others then learn from it and are convinced that there's these benefits. So that's probably, that was some of the thoughts I had on those answers. But in my view, the business case is that better monitoring and access to better information and information quickly will result in less interruptions to your facility. So in my view, there is this case for bringing technology on board. And less interruptions means less events, less incidences, and perhaps less cleanup costs. So although there might be an initial cost to set up and implement these systems and devices and sort of digitize your operation, if we can say that, I believe that there should be a net that should be netted off against these reductions in events and in incidences, and as I said, sort of any cleanup costs, or perhaps even on a social side, your complaints and grievances that might come up, and that also spills onto the sort of reputational side that might evolve. So yes, there's definitely a cost for initial setup, depending on how mature an operation might be on their digital journey. But I definitely see that there will be benefits down the line on bringing these efficiencies in. Lastly, just on that point, it's important, and from my experience on implementing our system in various operations, there's, on the operator side, there definitely needs to be the right resource involved in the process, not just the right resource, but a clear plan on how you're going to then sort of do this conversion from perhaps previously more manual methods to embracing technology. The management of change is important. You've got to manage that process carefully, make sure that there's the right awareness and education about what technology can bring, and sort of quell those fears that technology is going to replace jobs. Absolutely not. If anything, it's going to enable you to do your work better. And at the end of the day, it's just about reducing the risk profile that your dam can bring. So all of these are the sort of points we bring up and to help operators say, right, here's technology, but these are the steps and these are the pitfalls that we've seen on previous sort of implementations. Be aware of it. Let's both sides ensure that your drive to digitization or new technology is smooth and it gets fully embraced.
Thanks, Robin. And Todd, your thoughts on challenges, barriers, and solutions to those?
Sure, thanks. So building on what Robin said, in that reference sites are something that miners really want to look at in terms of what's out there and operating before they do an implementation. And especially on a big, large mine, they're really looking for those references, because large mines are typically a lower grade, which is why they're big. They're looking for some economies of scale, which means that they don't have a big bandwidth in terms of how much revenue they're bringing in versus how much they're going to actually expend. And they can't take a lot of extra risk. So it's about the risk management, I think is the first part of it. And so miners are looking at new technology and saying, I don't want to be first. They might not even want to be second. It might be first to be third, might be the right way to put it. So getting some of those reference installations can be difficult. Some of the technologies that I mentioned in terms of dewatering technologies like high density thickening and paste thickening and filtered tailings, those technologies have honestly been around for decades. So it's not that they're new and they don't want to be implemented. It's that there aren't the reference sites that are out there, and it's difficult to get a large miner sometimes at a big mine to implement those. And so one of the ways maybe we could look at managing that risk for a large miner is to get a consortium together, and that maybe a technology provider like FL Schmidt, a large miner, and a government could go together and say, we're going to partner on some tailings dewatering demonstration plant that proves these technologies out, so that no longer do the miners feel that there's a lot of risk associated with it before they implement it. The other thing is cost, and every technology solution has to be either there because of a regulation, or it has to be cost competitive, or the miner isn't going to do it. Let's just be honest. So either it has to be regulated or it has to be cost competitive. If you start with that premise, then the cost of some of these higher performance dewatering systems like paste thickening and especially filtered tailings, there's a lot more upfront cost that's required to implement those solutions, and that upfront cost has to be covered by the miner. So maybe there are some creative ways these consortiums with governments or regulatory agencies and technology providers like FL Schmidt could come up with to help alleviate some of those cost concerns that are up front, have a way that it could be paid with over time that would allow the miner then to have a similar cost profile as they would for a more traditional solution that's a slurry deposition. So I think if we look at both of those kinds of barriers and come up with some creative ways around managing the risk and managing the financing, I think there are some opportunities there for these better solutions to be out there in the marketplace.
And Evgeny, you told us before about the pivot from wet to dry tailings. Are you able to talk a little bit more about the challenge? Because I would imagine there are costs involved. Are you able to elaborate on that?
Sure, I completely agree with Todd that for a mining company to implement a project of this scale, or actually to spend money on anything, has to either make sense in terms of costs or some returns that you can make on that project, or it has to be regulatory sort of required or mandated. For us, the process of switching to dry stack wasn't challenging operationally. It was maybe a bit challenging philosophically, because people were asking why we're doing it. The sort of strong ESG credentials and the ESG agenda that is quite prominent in how we operate has helped us to make people get people on board with this project. We also quite confident that even though dry stack is a more costly process in terms of capex, in terms of opex, we think it's cheaper than the wet TSF, and at the end of the day, it makes sense not only environmentally and socially, but it makes sense also financially.
So I guess there's agreement there. I think, Robin, you mentioned as well, similar to Evgeny, that there's ultimately a return on investment on investing in the right technology.
Yeah, that's right, Nadav. And I just want to add one last point to what Evgeny was mentioning. I mean, also with this ESG becoming so prominent, I mean, those terms have been around separately for decades. It's just umbrellaed as ESG, and it's got a lot of attention for a lot of good reasons. But even with the tailings design and operation now, your closure costs, which haven't really been raised yet, but just a point I want to bring, your rehabilitation and closure costs are a huge component of a mine's balance sheet now. So being able to even manage that from in terms of liabilities is important, and maybe it's in the design of new facilities or how you're going to manage that now so that you don't leave that legacy. So just managing that component, that liability is also very key to these miners at the moment.
Yeah, one of the challenges with that is those closure costs are so far down the road that they can be almost nothing when you use a net present value and bring it back to today's costs. But agreed that at some point those are going to have to be dealt with. And I have seen where there are some regulatory agencies which are requiring bonds to be put up for those closures. And if they do progressive closure using dry stack tailings or filtered tailings, they can actually start to recover those bonds earlier. And that's an important component in making that technology be cost competitive and economically viable for some of these mines. I think that's an important consideration.
Actually, the bonds is something we discussed as well in another recent white paper on mine closure, and certainly in many jurisdictions that's already present. And I think some of the experts we spoke to for that paper and discussion certainly hinted at we can expect more of that in more jurisdictions as time goes on as well. Any further thoughts on any final thoughts on barriers and solutions before we move on to the next section?
I think just one last comment from my side. I was glad to hear a miner say that operating costs of filtered tailings can reduce the overall cost of the system and technology to be competitive with traditional slurry depositions. That's something that FL Schmidt agrees with has been trying to convince miners of. So it's good to see that that's actually being considered out there in the marketplace. That if you think of a big mine that's a 1 billion ton reserve, your operating costs go down by $1. That's potentially $1 billion savings over the life of the mine. That's even if you do, back calculations of net present values, that might be a $500 million savings in today's money. And that's a lot of money for anybody.
Okay, well, moving on to the final theme. So looking forward, say 5 to 10 years, what do you think will be the biggest changes we see in how miners handle tailings facility operations and management? Todd, would you like to
Sure.
offer some thoughts?
From where I sit, as I mentioned, we have lots of touch points with lots of different miners, and I really do see a cultural shift happening with miners. They are no longer a tailings kind of an afterthought. Hey, everything that doesn't produce money goes down this pipe and it just disappears. They're actively looking at it. They're considering what the implications are of the implementation of any of the technology they're considering. What are the safety risks? What are the environmental risks? And it's a real cultural change, not just on mine sites, but for bigger miners globally, they're implementing this cultural change. And I really do think that the seeds of change are first to change the culture, and then you'll start to see some of these other technologies come in that'll make all of these new tailings dams be safer because of that cultural change.
And Robin?
That was a great point by Todd. And just to add, from my perspective, yes, I think there'll be a much greater uptake of, digitization and being able to gather data, monitoring data, survey data, thermal data, any sort of vibrations or any aspects that could affect a facility, being able to gather that in real time, make it available to the right person in sort of real time. So I think there'll be a greater uptake on that. And also interesting with climate change, there will be a lot more focus on what risks climate change brings and how you firstly design and manage a facility. So, again, after ESG, climate change is very topical, and we're starting to sort of, I don't think we really know the risks well yet, and modeling is not quite there, but certainly I think in 5 to 10 years' time, we'll have a better idea of climate change risks, and dams are going to have to be designed accordingly. Yeah, thanks.
And Evgeny, from a miner's perspective, what may we expect to see in the next 5 to 10 years?
I guess I'll struggle to give you sort of the whole industry's point of view or the impression of how fast this process will continue to evolve. From Polymetal's point of view, we hope to reach the target of 15% of all tailings to be dry stacked by 2024. And then in the next 5 years, hopefully, we will manage to convert the same, if not the larger, share of our tailings into dry stack. So that's our plan, and that's what we have sort of budgeted for. And that's very important because we would like to back up our pledges by financial commitments and by making administrative and sort of personnel commitments that would sort of meet the requirements and meet the pledge on all counts, on all levels. I agree with the panelists that the biggest barrier is mental, is cultural. Once that has been overcome as a result of hopefully of this new standard which has been approved, then I think from then on it's just a matter of implementation, which is actually just a matter of numbers and resources thrown at it, as opposed to just pure resistance to adopt the new standard.
Okay, thanks everyone. That's all for our panel discussion on the future of tailings. Todd, Robin, Evgeny, thanks to all of you for your time and an enjoyable discussion.
Thank you.
Thank you.